Hi, everybody. It's Ms. Corcoran, and I'm here to give you a quick explanation about error bars because they are something you're likely to see on the AP exam. And if you recall, we did an M&M chi-square lab where we were determining significance between our expected and our observed values. And we used math and we came up with, well, what we saw is what we expected, so there's no difference, or what we saw was pretty different from what we expected, and we can prove that with math. So remember, our data means nothing without statistics behind it. And these error bars are a really great shortcut way to determine if there is a difference between a couple of groups. So take a quick look at this, and you've got this on your Schoology page. Excuse me. If the error bars overlap, and you may be even asked to create a graph with error bars. So it will give you a data point, and then it will say plus or minus one or two standard errors of the mean, and you will calculate the graph to the point and then go whatever it is, the numbers that they tell you. And I'll show you an example in a minute. But we want to look at this data right here and be like, wow, whatever this is, that is so much more than this one. But we really don't know what it means. And when you apply the error bars, you see an overlap here. And when the error bars overlap, that means there really is no difference. Any difference is strictly due to chance. So there's no like statistically significant difference. Here, there's less overlap. And in this particular situation right here, there's actually no overlap. When the error bars are so far apart and they don't overlap, that's when we can pretty definitively say, gosh, there is a difference between the two treatments, or there is a difference between what we observed and what we expected. So after you sort of listen to this, take a look. This one's kind of a hard example because they don't technically overlap right here. But you look at this and you want to be like, oh my gosh, chemical 2 has a huge impact on the length of roots over chemical 1. Again, this is kind of ambiguous. If they did overlap, we'd say, gosh, there really is no difference between chemical 2 and chemical 1. If they were really further apart, we could say, wow, there's a huge difference in the effect of chemical 2 on root length. So you're going to be asked in just a second to complete this 2018 AP Bio released question. It's one of the 6-minute long questions. It shouldn't take very long, where you're given 5 different sets, and you need to make some conclusions about that. But before we get to that, this is a released exam question where the student was asked to graph the effect of caffeine on memory of bees. So what they were given is this data right here. At the 10-minute time point, the control was 0.72 plus or minus 0.09, and the caffeine was 0.83 plus or minus 0.07. And then at 24 hours, it gives you a data point plus or minus 2 standard errors of the mean. So the student, and this is a good example, the student adequately graphed that. They titled it, they labeled their axes. At 10 minutes, the control, and here's their data point, and they just put in these error bars. Over here at 24 hours, they graphed it, and then they did the error bars based on the standard error that they were given. So that wasn't hard. That was straight up graphing. And then I believe it probably asked, determine if there's a difference. Let's see. Describe the effect of caffeine on each of the following: short-term and long-term. So the null hypothesis is there's going to be no difference. Well, what is the short-term effect? It sure looks like caffeine has an effect because the overall graph is higher. But remember what we said. When the error bars overlap, there's really no difference. However, if you look at the 24-hour data, this graph, I mean, you want to scream it to the heavens right now. Oh my gosh, there's a huge difference. But you can back it up with this statistical evidence that the error bars don't overlap. And actually, a really satisfactory answer when it says up here, based on the results, describe the effect of caffeine on each of the following. You'd say it does have an effect or it doesn't have an effect. And if it says justify, a very appropriate justification, if you say there is no effect at the 10-minute mark on caffeine of bee memory, the justification is the error bars overlap. Yes, you can absolutely say that as a justification. If you want to claim that there is a difference or caffeine does have an effect on B memory after 24 hours, the justification would be the error bars don't overlap. So it's such a gift that the College Board will accept that as justification. And you really need to understand and be comfortable and fluent talking about that.